In this lesson, we're actually going to start using sine, cosine, and tangent and show you what the actual purpose behind it is. Now, I do want to remind you the sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. That's going to be very important to us in our lesson today. Here's how we're going to use it. We're going to use it in right triangles to find missing side lengths. So let's start out with number one. First step is identify what type of problem do you have. Do you have a sine, cosine, or tangent problem? Here's how you do that. Find your angle and see which sides that this problem is dealing with. This is dealing with the opposite side and the hypotenuse. Go back. If you have a problem that deals with the opposite and hypotenuse, O and H, that's going to be a sine problem. You're going to write yourself a trig equation. Since it is a sine problem, you're going to do the sine of your angle. You always find the sine, cosine, and tangent of angles. The sine of your angle is equal to opposite over hypotenuse. You set you up a small equation, and then you're going to solve it. The sine of 32 is simply a number. Okay. Now, one thing we do have to do here is we've got to get x by itself. So let's do this. To solve this equation, just keep in mind again that this is a number. To solve this equation, first thing, I don't like this x on bottom, so let's mark it out and let's move it up here. Now that it's on top, you actually want to get it by itself. So what we're going to do now is to get x by itself, we're now going to mark out the sine of 32, and we're actually going to move it back down here. We're going to get x equals, because they're being multiplied, we're going to divide 11 divided by the sine of 32. Then you simply type that into your calculator, and you find out that x is about 20.8. Now there is a trick. Here's what I like to do. Let's go back to the original. Anytime you're solving one of these trig equations, or any equation for that matter, to where the x is on the bottom of a fraction, what you can actually do is just flip-flop these two. Okay, move the x up here, move the sine of 32 down here, just switch them, because it's actually kind of like a proportion. You can solve it that way. Okay, problem number two. First, identify your angle and see which side you're given. You're given opposite and you're given adjacent. This would be a TOA, or a tangent problem. The tangent of my angle is equal to opposite over adjacent. Now, this is kind of nice because the x is not on the bottom here, so it makes it a whole lot easier to solve. To get x by itself, mark out divided by 21, come over here and multiply by 21. Type this into your calculator and you're finished. X is equal to, or about, 78.4. So if you have this angle and this side length, then this distance right here would then be 78.4. Number three. Here's your angle. Identify which sides you're given. This is adjacent and hypotenuse. Adjacent and hypotenuse would be a cosine. So the cosine of your angle, which is 23 degrees, is equal to adjacent over hypotenuse. To solve for x, we're going to get rid of the 30 by multiplying. Type that into your calculator and you get that x is equal to about 27.6. Number four. Here's your angle. You're dealing with opposite and adjacent. Opposite and adjacent is a TOA of the SOHCAHTOA. So you're dealing with a tangent problem. The tangent of my angle is equal to opposite over adjacent. Now we're dealing with an x on bottom again. So what we're going to do is we're going to switch x and tangent of 41. So x is going to equal 15 divided by tan of 41. Now, if you work this out wrong, you've got to be careful. If you ever work out a problem to where one of the legs is longer than the hypotenuse, you know that that would be wrong. So here, when we type this in, we get about 17.3. Now, you got to be careful too. Make sure that when you're typing this in, that is the answer you get, because sometimes the calculator can be tricky about how to type that in. Number five, here's your angle. This is the adjacent, this is the hypotenuse. So adjacent hypotenuse, that'd be a cosine problem. The cosine of my angle is equal to adjacent over hypotenuse. The x is on bottom, so we can flip-flop them. That'd be 3 over the cosine of 64. Type that in and you get about 6.8 for a length for the hypotenuse there. The next one, here's my angle. This would be the hypotenuse, because notice it's across from the right angle, and this would be the opposite. So we're dealing with a hypotenuse and opposite. That'd be a sine problem. The sine of my angle is equal to opposite over hypotenuse. Again, anytime the x is on bottom, switch it, and you have 25 over the sine of 18. When you type that in, you get about 80.9. Now, the next section, we're going to be finding angle measures. Now, anytime you're looking for an angle measure, given the trig value and angle, use the corresponding inverse trig function to find the corresponding angle measures. What do we mean by inverse functions? Inverse sine. If the sine of theta is equal to x, then that means that theta will equal the inverse sine of x. To find an angle, you will either use inverse sine, inverse cosine, or inverse tangent. Notice how I'm reading this. Sine with a little -1, that's not sine to the -1 power. It's read as the inverse sine. The same way that when we switched our x's and y's to find the inverse of functions earlier, it's the exact same thing. So if the cosine of theta is equal to x, think of it like this. To move cosine from one side to the other, you just change it into inverse cosine. To move tangent from one side to the other, to figure out what your angle is, you change it to inverse tangent. It's the same way as if you've got x plus 3 equals 7. How do you move plus 3 from one side to the other? You do its inverse of -3. It's the exact same thing. So to move a sine, cosine, or tangent from one side of the equation to the other, you change it to the inverse. Now, notice you don't find inverse sine, inverse cosine, and inverse tangent of angles. You find the inverse sine, cosine, and tangent of numbers, and it will tell you the angle. So let's give you an example. Find the measure of theta. Step number 1, do the same thing. Here's my angle. I'm dealing with hypotenuse and adjacent. That's a cosine problem. The cosine of my angle is equal to adjacent over hypotenuse. Now the next step, how do I get theta? How do I figure out that theta? You mark out cosine and you move it to the other side. The way you move it to the other side is turning it into the inverse cosine. So we're going to find the inverse cosine of 18 over 23. Now the inverse cosine button is normally right above the cosine button on your calculator. In order to access it, usually you're going to have to hit like a secant button or a shift button in order to get it. So we're going to do the second cosine of 18 over 23, and that's going to give us right at 38.5 degrees. Next one. Here's the angle I'm looking for. This is my hypotenuse, and this is my opposite side. So this would be a sine problem. The sine of my angle is equal to opposite over hypotenuse. To figure out my angle, I've got to move my sine over. I'm going to do so by taking the inverse sine. The inverse sine of 5 over 21. And that means that my angle is going to be about 13.8 degrees. And this is probably pretty much drawn to scale because that's a pretty tiny angle there. Number 9. Here's my angle. This was the opposite and adjacent. That'd be a tangent problem. So the tangent of my angle is equal to opposite over adjacent. So therefore, to find my angle, move the tangent over by doing the inverse tangent of 17 over 18, and that means that your angle is going to be about 43.4 degrees. Number 10, here's my angle. This is opposite and this is adjacent, so we got another tangent problem. So the tangent of my angle is equal to opposite over adjacent. To get rid of my tangent, to move it to the other side, I change it to inverse tangent. So I'm going to do the inverse tangent of 39 over 20. And that tells me that my angle is about 62.9 degrees. Number 11. Here's my angle. This is opposite and hypotenuse. That's a sine. The sine problem or sine of your angle is equal to opposite over hypotenuse. So therefore your angle when you move sine over would be the inverse sine of 29 over 52, which gives you 33.9 degrees. And the last one of these, here's my angle. This is adjacent and hypotenuse. So that would be a cosine problem. The cosine of my angle is equal to adjacent over hypotenuse. So therefore my angle would be the inverse cosine of adjacent over hypotenuse, which is going to be about 50.8 degrees. Now, next up, we're going to solve triangles. Now, what we mean by solving triangles is finding every angle and finding every side. Now, a couple of things that can help us solve triangles, like with this first one, the three angles in a triangle. Remember back from geometry, the three angles always have to add up to 180. So if you have a 72 here, a 90 here, add those, subtract from 180, and you're going to get measure of angle B has to be 18 degrees. So that's one trick that we can remember. Or since it is a right triangle, since this is 90, that means that these two would have to add up to the other 90. The other tool that we can use is Pythagorean theorem sometimes. So keep those two in mind. So let's go ahead and find, we'll start out with side BC first. We'll call it our X, and we're going to do the exact same process. Here's my angle. I'm dealing with opposite and adjacent, so that'd be a tangent problem. The tangent of my angle is equal to opposite over adjacent. To figure out what X is, since it's divided by 15, we're going to multiply by 15, and we get that X would have a value of 46.2. So therefore, side BC is 46.2. Now let's find side AB. Let's change to a different color. And we'll call this side Y. You can call it any letter you want to. Now, could we use Pythagorean theorem? Sure. The only problem is this is a rounded answer. That's not an exact answer. So if you use Pythagorean theorem, you need to round that off to more like 5 or 6 decimal places to make this more exact. I'm going to use trigonometry because this is exact, so therefore I'm going to use another trig ratio to find y. So here's my angle. Now I'm dealing with this side and this side, which is adjacent hypotenuse. So that would be adjacent hypotenuse would be a cosine problem. The cosine of my angle is equal to adjacent, which is 15, over hypotenuse, which is y. Since the y is on bottom, again, I can flip-flop these, and I can do y equals 15 divided by cosine of 72. Type that in, and you get 48.5. So therefore, my y, which is AB on my triangle, is 48.5, and that triangle is now solved. We found every side and every angle. Next one. We have one angle, 34 degrees. You can take that from 180, which means this would be not 46, but 56. I can't subtract. So angle R is 56 degrees. So that one's pretty easy. Now let's find, it doesn't matter which one you start with. We'll do RT first, I guess. And you can actually use either angle. Just to make things different, this is exact. I'm going to use this angle this time. You can do let's see, I'm looking for X, so this be adjacent and hypotenuse. So that's going to be a cosine. So the cosine of 56 is going to equal adjacent over hypotenuse, which brings up an interesting point. The cosine of 56, since it's x over 42, is the exact same thing as the sine of 34. Because if you did the sine of 34, you also get x over 42. So obviously, in order for this to work out equal, then these values must be the same. The cosine of one angle and the sine of its complement, notice these two angles add up to 90, will always be the exact same value. So it's like the cosine of 30 and the sine of 60, or the cosine of 20 and the sine of 70 would always be the same. So once you solve this, move the 42 by multiplying, and you're going to get that x has a value of 23.5. So therefore, RT is 23.5. So now let's find our other side length. Let me change colors, and we'll find, we'll call it Y. We'll find this side. And again, you can use either angle. You can use this one if you want to. If you use this one, this would be adjacent over hypotenuse, which is, again, cosine. However, this time it's the cosine of 34. Cosine of 34 is adjacent over hypotenuse. To solve that, we simply multiply by 42. When you type that in, you're going to get that y has a value of 34.8. So therefore, ST is 34.8. Next problem. Now we're looking for angle measures. So what we're going to do, it doesn't matter which one you start with. Now we'll find JL in just a second, but we're looking for angle K. We'll start with it. If we're looking for angle K, this would be the adjacent and hypotenuse. That'd be a cosine problem. The cosine, I'm just going to call it K The cosine of K is equal to adjacent over hypotenuse. To figure out what angle K is equal to, you're going to move the cosine over by doing the inverse cosine of 7.6 over 8. And that's going to give you a value of 18.2 degrees. So angle K is 18.2 degrees. Now, do we have to do that again? No, you could. To find angle L, you could do the inverse sine of 7.6 over 8. However, the three angles in a triangle always add up to 180. The two acute angles in a right triangle always add up to 90. So that leaves you with 71.8 degrees for angle L. Now, how do we find JL? You could use some trigonometry, use the angle that you just found. However, again, it's a rounded angle, so make sure you get about 4 or 5 more decimals if you're going to use it. Now, the easiest way, you've got two sides. Why not use Pythagorean theorem? A squared plus B squared is equal to C squared. If you have two sides of a right triangle, the easiest method is always going to be Pythagorean theorem. Square the 7.6, subtract it over, work it out. I'm not going to do all the steps, but you're going to get B has a value of 2.5. Okay, next problem. Again, Pythagorean theorem is going to tell you the missing DF side, so you're going to do 21.21 squared plus 22.5 squared equals C squared, and that's going to give you a value of 30.8. So let's go ahead and write that. And again, that's just simple Pythagorean theorem. Now let's find our missing angle measure. We'll look for angle D first. We're given the opposite and adjacent sides. So that's a tangent problem. The tangent of angle D is equal to opposite over adjacent. So to find angle D, we're going to move tangent over by doing the inverse tangent of opposite over adjacent. That's going to tell you that angle D is equal to, we'll round to the nearest angle measure on this, right at 47 degrees. So we'll put 47 degrees on angle D. And a reminder that the three angles add up to 180, or these two angles add up to 90. So since this is 47, this would have to be 43.